Today we'll give a brief introduction of ITRI's autonomous vehicle technology. Let me give a brief history of the self-driving car technology effort here at ITRI. So we started a little bit more than 4 years ago, back in 2018. Since then, we have become the first team in Taiwan to pass government testing and to obtain the first self-driving car license plate in Taiwan. Since then, we've also successfully collaborated with multiple local governments to do some public self-driving demonstrations, including with Hsinchu City and Taoyuan City and Taichung City. In addition, we also have a lot of private sector collaborations, both domestically and internationally. So this includes, domestically, we worked with Hsinchu Logistics Company, and internationally, we've worked with several renowned car manufacturers and highway operators. So one of the main selling points of our technology is its modular architecture. So it consists of several subsystems that can be easily adopted to various operating scenarios in various vehicle types. So shown in this slide, you can see actual cars on which we have successfully deployed our self-driving technology. So this includes, on the top left, purely electric vehicles, and on the bottom left, we have diesel buses, and in the middle, there's the mid-sized truck for logistics applications, and top right, there's a hybrid vehicle, and on the bottom right is a freight truck with a trailer box attached to it. So all of those vehicles, all those vehicle types can, our technology can be successfully used on. So our technology stack consists of these subsystems shown on the right. So this includes the action and control module, perception, mapping, localization, tracking, prediction, and so on. So these subsystems will can be interfaced with these various sensor types. So that includes the camera, LiDAR, GPS, radar, and even external communication sources, such as roadside units and some control center living in the cloud. All these real-time signals will get passed into our subsystem, which will then form some understanding of its surrounding with the help of these various signals, and to compute the control signals to the drive-by-wire system so that the car can do a safe and performant driving. One of the most important parts for ensuring safety and performant driving, self-driving, is the availability of a HD map. So a HD map will provide, it's a centimeter accurate map that allows the vehicle to get localized onto it so that the vehicle knows where exactly it is in the world. And it also provides additional rich information about the surrounding that the self-driving car may not be able to directly perceive with its sensors. So we provide tools that allow us to create these HD maps at scale. So on this slide, you can see some examples of HD maps created using our tools. Immediately below the text is the point cloud map and vector map of the ITRI campus, and the bottom left image shows the scale that is achievable by our mapping tools. And in the middle, we have mounted on a car the mapping sensors this low-cost mapping toolkit that we built. And on the right, this video shows the self-driving car being localized onto the HD map. So the perception module is responsible for taking all these real-time sensor streams and combining them, analyzing them, and in real time forming an understanding of its environment. So this includes knowing where the location and the speed of its surrounding cars and pedestrians, even scooters. And also on the right, so let me play this video. So this perception system is able to know about the location and the speed of surrounding objects. And it's also responsible for analyzing the image and finding traffic lights and correctly determining the state of the traffic lights. In addition to these sensors for sensing the vehicle surrounding, we can also augment these senses with information from farther away. So like roadside units with cameras from farther away or even around a building corner can share its camera. It can share its view through wireless communication with the vehicle. So this will further expand the horizon or the amount of the field of view that the vehicle has, so it could be more safe and perform more performant driving. So our technology stack includes software to support this kind of connected V2X communication. So in this video, you see the car's real-time information is being passed on to, it's being collected and aggregated. Its status is being monitored from a cloud, from a control center in the cloud. So you see the location of, so the top view is the car inside the car, and the bottom view is what is seen from the control center. So we can see where the car is, and we can monitor various statuses of the car. Safety is the most important part, is probably the most important requirement of self-driving cars. So we place a lot of emphasis on safety. So we adopt a lot of safety standards, including ISO SOTIF and ISO 26262. And in addition, we also develop a collection of simulation tools that allow us to simulate and test the functionality of our subsystems prior to actual deployment in real world. So these simulation tools include like purely virtual simulations, and it also includes these mixed reality simulations where so part of the signal being inputted into the car is real signals, and it's augmented by these fake virtual signals. So I'll quickly show a video of this. So you can see that the car is actually driving on the road, but that blue box in front of it is a fake car, is a virtual car that is being injected into the system just to test its behavior. So you can see the car, once the car has pulled up to the side, then our car is able to successfully overtake it. And here you'll see a scooter cutting in front of it, and our car is able to successfully slow down. And pedestrians that suddenly run into the street, our car can also respond accordingly. So being based in Taiwan, we're subjected to a lot of very challenging traffic scenarios, such as these very dense motorcycles, a lot of motorcycles surrounding you, and a lot of illegal parking and occasionally stray dogs running out in front of you. So all of these challenging scenarios has forced us to continue to innovate, and the result of which is we have a much more robust, thanks to these challenges, the result of it, which is a very robust self-driving system that is able to handle these very, very challenging situations. So this is our car driving in a typical Taiwanese street. So there's a lot of illegally parked cars on the side. And our car is able to adjust its trajectory accordingly based on these illegally parked cars. So that concludes our brief introduction of ITRI's self-driving car technology. And we look forward to hearing from you if you have any further questions, or if you would like to learn more about our technology. And as always, we're always looking for new ways of using this technology to solve real-world problems. So we'd love to hear from you if you have such a use case. Thank you.